instruction could be instruction number 4. Start each question on a new page. You make our marking so easy. And we shall see your answers clearly. All right, let's go to question number 1. Kelly traveled from Robertson, a town in Western Cape, during the school holidays to visit his auntie Nina. A part of the map of Robertson that Kelly used for his journey is shown below. Study the map and use it to answer the questions that follow. When we look at the questions, that follow, we see that we see the map here. But what I have analyzed so far is that the compass change. The north is facing that other side. Take note of that. The map, when you look at the map, it has a compass. Does it have a scale? It has streets and has some roads there. All right. Here we go. Name the road that passes through Robertson Winery and Robertson Wine Valley. When you look at these two places here, let me highlight for you. We have the Robertson and Wine Valley. There we go. This road that passes through it was R60. So your answer here is supposed to be R60. Okay, determine the general direction. Determine the general direction of Robertson Small Hotel from Center Lodge Guest House. So Center Lodge, we are here. Remember, this is north. So we are heading towards Robertson here. So definitely you're going what? West. So the answer then becomes west. Name 2 grocery stores indicated in the map. Name 2 grocery stores indicated in the map. Let's highlight them. Grocery stores. This icon here would mean a grocery store. This is the trolley. So we have Checkers. The other trolley is here, indicating the Spar. They said 2 only. 2 only. That means our answer there is supposed to be Super Spar. And what? Checkers. 1.1.4. Identify the name of the high school indicated on the map. The high school that was indicated, the icon is right here. And the high school, Robertson High School. So we shall come here and say Robertson High School. School. 1.1.5. Kelly arrived at Robertson at 11. At 11:03. Write down the time Kelly arrived in words. So simply meaning it's 30 minutes. It's 30 minutes. It's 30 minutes. You say 3 minutes. 3 minutes past 11. But then we don't know whether it was in the evening or we don't know whether it was in the afternoon or morning. So we can't say anything here. All right. Let's come back and see the journey. All right. Identify the type of map that we have. This is called a street map. It's called a street map. 1.2. Mr. Stolcom owns a house. A floor plan of the house is shown below. Study the floor plan above and use it to answer the questions that follow. Determine the number of windows on the western elevation of the floor plan. Western. That means eastern. Determine on the eastern elevation. This top is the north, this is the east, this is the west, and below is the south. So we are looking for windows on the eastern side. So we have 1, 2, 3, 4. So there are 4 windows. Determine the number. So we say 4. How many bedrooms are indicated on the floor plan? So we have bedroom 2, bedroom 1, the master bedroom. So there are 2 bedrooms. We shall say there are 2 bedrooms. There are 2 bedrooms. Bedrooms. All right, question number 1.2.4. Mr. Tomel stated that the perimeter of the floor plan is 45.06 meters. Explain the word perimeter in a given context. We shall say perimeter is the total distance around the floor plan. The total distance around the floor plan, the total distance around the house, the total distance around the building. All we need is to see the word total distance. All right. Select from the options below. Select from the options below the correct unit that can be used. The correct unit that can be used for the area of the master bedroom. Write only the letter. So the question is 1.2.5. You are supposed to write the letter as B. Why do we choose B? Because you're looking at area. And area units of or is to be what? Squared. All right, we look at question number 1.3. The wife bakes homemade rusks for her family. The recipe that she uses is shown below. Question number 1. How many grams of all brown white flakes are used? All you come here, come. Identify what? All brown what? Risk. What are the grams? They are this much. So this becomes 240 grams. Each batch of rusk needs to be baked for 55 minutes. The last batch was taken out of the time indicated in the watch alongside. Convert 55 to hours. We divide by 60. 60 divided by 60, we say 55 divided by 60, which is approximately 90. Approximately 0.1. We're rounding off to 2 decimal places, which is approximately an hour. So if you round off to all numbers, write down the type of time format. Write down the type of time format displayed on the watch. This is called what? Analog. Analog is a type of display. The other one is what? Digital. The 24-hour system. So write down the time indicated on the watch in 24-hour systems. Another thing you'll be facing is you don't know whether it's in the afternoon or in the morning. So, or if it was in the morning, you would say 0:04. It's in the afternoon, you would say, if it was in the afternoon, then it would have been this much. digital format. Digital format. $16.30 if it was in the afternoon. All right, question number 2. Northwest is the 6th largest of the 9 provinces in the hub in South Africa. It has the area of 40,495 square miles. And the population is about 4.1 million people as 2021. About 30.6% of the people in Northwest Province live in Potchefstroom and surrounding areas. All right, question number 2. You look at the map. Write down the name of the town that's farthest to the southwest of Mafeking, as shown as the campus. Southeast. Okay. Write down the name of the town that farthest to the southwest of Mafeking, shown on the map. So we shall come here southwest of the. This is Mafeking. Okay, then you this is it. Question number 2.1.2, we are asked use a ruler to measure the distance as the crow flies. Now, when you hear this word, it simply means a straight line from Lichtenberg to Tang. Give your answer in millimeters. Take note of that. Even though you measure in centimeters, you can multiply by 10, you get the answer in millimeters. This is important. Millimeters. Now let's go to the next and we see. The next year A, here we go. We are supposed to measure the distance from here to Lichtenberg, which is this place here. When I measured, I got 65. I got 65 millimeters. This will change according to people's rulers, but the range we can give you is 2 more units. 2 more or 2 more, 2 less. All right. So don't worry about when if you got 60, 63, well and good. If you got 65, 67, 66, it's fine. Okay. Use the scale on the map to calculate the actual distance in kilometers between Linsenberg and the. So now, how do we use the scale here? We use the scale, we use the scale, we use the scale, we use the scale as we shall go and see on the map what scale is given. The scale that was given, it's this here. So all you had to do, it was to measure from here to there. In that you get the distance, which is actually also you should measure it in millimeters. All right. So I, for one, when I measured, I got 27 millimeters. So simply meaning the 27 millimeters are representing 80 kilometers. But the question wants you to change the distance that you measured from here to be changed into real life. So this is so straightforward. If 27 millimeters give you 80 kilometers, what about if you have 65 millimeters? What will it be? What do we do? We cross multiply, which was supposed to be 65 times 80, and I divided by my 27. Still here, since we are using different rulers, the answers are bound to change. Answers are bound to change. Remember, we have 65 times 80, 5,000, 5,000, and divided by 27. So the answer here, I have it as 192.59, which is approximately 193 kilometers. Why am I saying kilometers? Because the missing part is on the side of kilometers, and we never change these kilometers to millimeters. All right. This is the answer that we have there. All right, let's continue. The answer that we have there. The next question is, all right, that was question number 2.1.3. Please don't get scared according to your measurements. If you measured, you go to this answer. Some people have measured the scale to be 30 millimeters. That means the 30 millimeters will equal to the 80 kilometers. Because the scale has changed from mine, that means also your final answer will change. But does not mean you're wrong, because we're using different rulers. All right, now this is 65 millimeters, simply meaning it will be a certain number there, cross multiply, which will become 80 times 65 equals to 30 with the unknown. What do? We look for the unknown, we divide through by 30, divide through by 30. This goes with that. So the unknown now changes to, 80 times 65 divided by 30. And the unknown became 173 kilometers. All right. Yes, they're asking us here. Determine the actual number of people living in the rural area, in the rural parts of the province. We shall come back to this scenario here. They have told us this is the area of the province. This is the area of the province. And this is the population. But of this population, 3.6% of the people in northern live in Oshire and the surrounding area. That means the rest live in rural parts of the province. So they're asking us down here, they're asking, determine the actual number of people living in the. So in your head, you know very well, without tampering with it, the number is at 100%. So of this 100%, if you remove if you remove 3,6, what do you remain with? 100 minus 3,6, you remain with 96,4. Remember, it's still a percentage. So 96,4 are the people who are living in the rural areas. Why? Because they told us 3% of the people in the northern west are living in that town there and the surrounding, and the rest live in the rural parts of the province. So the 96,4% lives. So 4% of what? Of the 4,1 million. Please, at this moment in time, leave it like this. Multiply. Remember, this symbol here means over 100. So put this over 100. Do that for me, 96,4 divided by 100 times 4,1. You get your answer as 3,952. Remember, we are dealing with that median. If you want it in the actual number, which simply means this one you are supposed to multiply it by 10 to the power 6, or supposed to multiply it with a million, and you got your answer as 3,952,400 people. Someone else would have looked for, someone else would have done it this way. Someone else would have done it this way. All you do, look for the 3,6% of the 4,1 million. So 3,6% of the 4,1 million. Keep it in your head that this is median. All right? This is A. So because now these ones are the ones in town. So what about those in the rural area? So we shall say 4,1 minus 0,1476. What answer do you end up having? You still have the same answer as ours. Leave it on the calculator. At this moment, what do? Multiply with million. Still the answer will come back to same. They wanted the actual number. Okay, 2.1.5. Convert the land area of the Northwest Province to the nearest kilometer squared, given that 1 kilometer equals to 0.62137,119 miles. What you're going to do for me, you ask yourself, let me do it down here, I'm doing 2.1.5. We are determining the area which is already in square. It's in square miles. We want it to become square kilometers. But they have told you if you only have 1 kilometer, you have an equivalence of 0.62137119 miles. Remember, these are just plain, they are not yet square. So if you want a square kilometer, that means it's going to be a square. Also, you're going to square this side. Together? So here we go. We shall go back to the scenario, check very well. What do we have? They have told us you have 40,495 square miles. We want them to become kilometers. So you come down here. Between these two, we want it to come this side. So here we shall say we have the 40,409. These are square miles. These are square miles. So what are we going to do? We shall cross multiply. Remember, there's a square part here. So it's going to be 0.2137,119 squared times the unknown should give me 495. These are square miles already. What am I doing? I will divide through by the same number squared, and I'll divide through by the same number. So now this will become 40.95 divided by 0.613.711. Is kilometers what? Squared. This was supposed to be the answer. This was supposed to be the answer. Okay, they said to the nearest kilometer squared, simply meaning it's one. That was question number 2.1.5. We look at 2.1.6. 2.1.6, it wants us now to calculate the population density of Northwest Province. The formula is already given here, so the population, we saw it as 4,100,000. So we are dividing now with the area that we've just got, because they want the answer in number of people per kilometer squared. So the answer we've just got, we got 10,000. We've got 104,802. So here the answer that we need to get. Let's do it there and we see what we get. 4,100,000 divided by 104,800. So this became 39,09 people per kilometer what? Square. But remember, people can't be in halves. So this is otherwise, it's what? We make it 40. 40 people per kilometer what? Square. Two point two. One of the activities participated, or one of the activities to participate in while in Northwest Province is to ride an aerial cableway located at Hotspot Port. Read the following information and answer the questions that follow. Each of the cable carries 6 people. Take note, put that in your mind. Then each cable travels a maximum, each cable car travels at a maximum speed of 5 meters per second. Take note of that. These are not kilometers per hour, but 5 meters per second. Then it takes a cable 5 minutes to reach the top of the mountain. It takes 5 minutes to reach the top of the mountain. Then a cable goes to the top of the mountain 7 times. 7 times. The maximum weight of passengers that the car can carry is 480. The tourist is 30th in the queue. waiting to go to the top of the mountain. At what time will she reach the top of the mountain if the first group in the queue boards at 20 minutes to 10? So first and foremost, you're going to look for how many, because in a 30th, that means these are 30 people. The car takes 6 people per route. So first and foremost, we have to find out how many routes will they be, because now 30th, we shall divide this by 6, so there will be 5 trips. All right. Then how much time will it spend? Now, of the 5 trips, we need to know, or we need to calculate. 1, the time used going up. So we multiply it by 5. And also the time to come back, bring them down, times 2. Times 2, because I'm counting the time. Let me see. The car cable goes to the top of the mountain every 7 minutes. After 7 minutes, the car goes up. But it has to go up and it has to come back down. All right. Assume that there is only one cable car operating on the day and it's filled to the capacity for each trip. You understand? For each trip. When we hear the word trip, that means to and fro. Because it has to take people, the first 6 people, to the top of the mountain, then it comes back to pick others. So if it takes 5 minutes to go, we approximately take it to say 5 minutes to come back. So how many minutes has it used? We shall say the 5 trips, each is 10 minutes, plus the 7 minutes it takes for each trip. So this becomes what? 35 plus 50. 35 plus 50, which we end up having 85 minutes. So we're not interested in 85 minutes. We're interested in what time will the person reach up there. So we shall divide this by 60 to change it into hours. So 85, actually, me looking at it, is 1 hour and 25 minutes. So we shall come, because 85, it's 1 hour, 25 what? Minutes. We shall come here and say, we shall add. So 9:43 plus 1:25. The answer becomes 11. So it should be 11. 8 minutes past 11. 8 minutes past 11. Calculate the distance in meters traveled by the cable car to transport people to the top of the mountain. You may use the following formula. They are saying the distance in meters traveled by the cable car to transport people to the top of the mountain. Here we are just looking at the one going up. It's fine. But then now, take note of the formula that I have given you. The formula starts with speed equals to distance over time. You're not interested in time or speed. You're interested in distance. This is when we employ our triangle which equals to speed equals to distance over time. We are looking for distance. That means distance equals to speed times time. So do we have the speed? We already saw it as 5 times. Do you have this the distance? Sorry, the time. To go up, we have the time as we have it as 5 minutes. We need to change this to seconds. That's why we multiply by 60. The reason why I'm changing it to seconds because the speed given to us is 5 meters per second. So we cannot have minutes here. So this becomes 1.5 meters. Let us look at question number 3. Question number 3. Question number 3 says, Mrs. Semenya gave birth to twins, a boy and a girl. She monitored their weight over the first 6 months and summarized it as shown in the table below. The weight of the baby is over 6 months. At birth, this is what they had. After 1 month, 2 months, 3 months, 4 months, 5 months, and 6 months. All right, so there we go. They want to use the information in the table 1 above and growth chart shown in the next chapter 2. Determine which description correctly represents the twins' growth over 6 months. Write down the question number and followed by the true or false. If the false, then correct the statement. The baby girl lay in the 10th percentile when was born. When she was born, let's go there and you see. So the baby girl lay 10th. We say we come here and you see. Let's say it's false. Line between. Oh. Okay. When the baby boy was 3 months, when the baby boy was 3 months old, 10% of other baby boys were heavier than he was. This is 25. So they're asking us When the baby boy was 3 months old, only 10% of the boys were heavier, 25. 10%, this is what? It's on the 25th percentile. Simply meaning false. At what time? At the time the twins were 6 months old, they were both they both lay close to 50, say true. 6 months. Let me ask you, 6 months. Look at that dot. I think we should work at the same time. The baby body mass index increases a little more than this is supposed to be. Question number 3.2. Due to the increase in the size of the family, Mr. Masenya decided to purchase a bigger geyser. The family purchased 200-liter geyser, twice the number of their old geyser. The table shows the dimensions. Okay. Write down the dimensions of the old geyser. Remember, how do we get the old geyser when they have not? The new one is twice the size of the old one. So new one is twice the size of the old one. The old geyser is supposed to be at 100. This one here. They're asking, write down the dimensions of the, so the old one is supposed to be 55 by 840. The dimensions are 550 millimeters by 840 millimeters. Calculate the circumference of the base of the new geyser. Circumference of the base. So this one equals to pi d, which is 3,142 times the 550. It became 1,728.1. We look at question number 2.3.3, 3.2.3. This another claims that because of the new geyser, has twice the volume of the old geyser, the surface area of the new geyser will need, or will also be twice, of that of the old geyser. Verify using yours. So number one, we are looking at surface area. We shall look at the surface area of the old. The surface area shall say, or we shall look for the surface area of the old. Surface area of the old. Take note, the old has a diameter which is different. This one here, 100. The diameter is this much, but the height has to change. We shall say, we're looking at surface area. So surface area, we need 2 pi r into r plus h. We shall need to look for these values and substitute them in. Becomes 2 times 3,142. Okay. So the radius of the old is a millimeters. We shall come here, substitute it in. Plus the length. 840. So substitute and we see 2 times 3,142 times 275. We're looking at surface area. So we look at this was the old one. Let's look at the surface area of the new. All right, let's repeat this and we see. Remember, we are comparing or we are finding out whether the surface area of the new geyser is the same, sorry, it's twice that of the old geyser. What we need to know is to find out what's the surface area of the new geyser, and we find out what's the surface area of the old one. We need to find out what's the surface area of the new geyser, and we have to find out what's the surface area of the old one, and we need to compare the two. Take note that the old geyser, it had its dimensions which way. We said this was the old geyser, so its dimensions are these ones here. So we have, this is the diameter and this is the length. So in surface area, we are looking at actually, let me see here. And the formula given here, which is true, it's fine. We can see how we can deal with it, but if you don't use that one, it's fine. You know the one that we usually use, which is 2 pi into r plus h. But I'm here looking at this. This is the same as circumference, pi d into r plus h. And use this if you don't mind. Anyway, the old geyser, it has a diameter of 550. Divide this by 2. Why am I dividing? I'm looking for the radius. which is 275. This is my radius. Then I substitute into the formula which says 2 pi into plus h. In this case around, we don't have h, but we have what? We have the length. So we shall say 2 times 3, 142 times our radius. Open brackets, come back with the radius, plus our length, the length of the old geyser was 840. Do everything here. Do everything. This is 1728.1 times so we get the answer there. We get the answer as this much. Now let me see, 3,140 times 2 times 8 times 27 plus 8. When we multiply these two, we have 7, 8,1. We have that much. Remember, this is surface area. Then we look at the new one, still using the same method. This was the surface area of the old one. The new one will be 55 also, which is the diameter times 3 times the pi, open brackets. The radius is still the same. However, the length has changed. 1,470 times 275 plus 1. We multiply this to get the answer as this is 30. Millimeters, right? Wait, but remember we are proving whether it's twice, so we need to divide this by 2. If we divide it and we get the answer as the odd one, then the claim is right. But if we don't get the same answer, so the claim is wrong. So we divide this by 2, we get so the claim is what? Incorrect. The claim is incorrect. The claim is incorrect. 3.2.4. 3.2.4, we are here. Mr. Masanya wanted to be sure that the stated capacity of the geysers is correct. So he performed the following calculations. Old geyser, he took this and did this. Identify two possible errors that were made in these calculations. Remember, we are looking at capacity. And indeed, this is right. But the radius has to be squared and everything. But now, when you take note of it, he did look at the radius. He used the diameter. So possible number one error, he used the diameter. He didn't use the radius. That's error number one. Number two, when you look at these values here, if you're to change millimeters cubed to centimeters cubed, you're supposed to divide by 1,000. So when you divide by 1,000 here, you don't get this. So this was another mistake. It was about what? Conversions. Those were the two mistakes. Calculate the capacity of the new 200-liter geyser. Round off your answer to the nearest liter. So remember the new geyser that we have already the diameter as, they have given us the diameter as 550 millimeters, and its length is given as 1,470. 1,470. These are millimeters also. The final answer has to be in liters. So what do we do? Since they have given us the equivalence of 1 centimeter cubed equals to 1 liter, we also need to change this into centimeters. What do? We divide by 10, divide by 10. Here you end up having 55. That is the diameter. We divide by 2, end up having 22.75. Is it true? 55 divided by 2, 22.75. So this will become 27.5. This is our radius. Now these have become centimeters. When we divide this also, we have got the answer as centimeters. So now you're good to go. Why am I using centimeters? It's because of the conversion factor here. So I will come and say 3,142. I'm using this formula here, times the radius, which we already have, times the length, which we already have. 3,142 times 27.5 squared times 147. We end up having 34,929. Sorry, it's the 349,292.21. So these are centimeters cubed. Let's divide this by 1,000. When divided by 1,000, we are changing it to capacity in liters, which becomes 349, these have become liters now. But they say round off to the nearest liter, which is approximately is 349 what? Liters. So here they're saying, should Mr. Masaya be happy of the new geyser? Yes. Provide a research support because he has put more than the 200 liters expected. All right, we look at question number 4. Question number 4. The diagram below shows the deck plan of MS Eden sailing ship. The MS Eden is a 35-meter long sailing ship. Refer to the deck plan and answer the questions that follow. We have the ship's dimensions, which the dimensions are the saloon, 13 meters by 4.7 meters, an area of 61 meters squared, a platform of 4 meters by 4.75 meters with an area of 19 meters squared, upper deck with 8 meters by 4.8 meters with an area of 40 meters squared. All right, this is how the ship looks like. Take note of that. Look at it. This is how it looks like. Then we have the upper deck having these dimensions. They're saying, or they're asking us, write the width of the restaurant. The width of the restaurant is 55 meters. Determine the approximate length of the restaurant area. I told you. Now, length is missing. Remember, we are looking at what? We're going to use what? Area. To ask us how do you get the area? Area equals to L times B. So the area, already we have it from the area. We already have it here given. So we shall say our length will equal to 117 divided by B, which is the width. So our L will equal to that. Looking for L, it's A divided by B. If you're looking for B, it's A divided by A. If you're looking for A, okay, you're continuing and you're saying 117 divided by 5,5. And the answer becomes they said, yeah, which is approximately 21 meters. A stronger rail needs to be inserted around the perimeter of the upper deck. Around the perimeter of the upper deck. 36 meters of the rail was purchased. Determine, showing all calculations, whether the 36 meters of rail is enough. But remember, we are looking at perimeter of the upper deck. So we shall say 2 into 8 plus 4,8. What answer do you end up having? 12,8, and the answer became the answer here becomes 25,6 meters. So it will be enough. It will be enough. 4.1.3. Study the deck plan and the ship's dimensions as provided the diagram. Identify 2 calculation errors that were made in the ship's dimensions and correct them. Let's go up here and we see they're telling us to look at this. When you pick your calculator and you multiply this here, 13 times 4,7 But that's what they're telling us to check. Oh, we have 61,75. So this, the calculation, the area of the saloon, the first area. Then we come to the second one, 4 times 4 times 4,75. It's 19. This is fine. We come to 8 times 8 times 4,8. We have 38,4 meters squared. This is wrong. So the two mistakes that were made there, there were the two calculations: area of the salon and area of the upper deck. There were two. Yes, we are talking of area of the salon and area of the upper deck. All right, the upper deck needs to be, okay? The upper deck needs to be packed with boxes of the following dimensions. Okay, the height of, okay. Determine the number of boxes. Determine the number of boxes on the upper deck if the boxes are packed facing up with the length, look at that, length across length and width across width. Here, we've already taught this. So simply meaning the length of the box is facing the length of the deck. So we shall do this and find out. We shall say the length of the deck divided by the length of the box. That's what they are telling us. So remember the length of the deck, we are looking at the upper deck. Ne? So the dimensions are here, 8 meters by 4. So the length of the deck, may I write them here? Length of the deck is 8 meters. Then the width of the deck is 4, these are all meters. So here we shall say length of the deck, which is 8 divided by 0,65. Then the other one, which is the width of the deck divided by the width of the box, which is 4,8 divided by 0,42. So here we get the answer as 8 divided by 0,42, which is approximately 4 boxes. And we have 4,8 divided by 0,5. And here we have 11, which is approximately 11 boxes. So what about the layers? The layer, the height of the box is this much, but it's in centimeters. Yet the height of the deck is in meters. This centimeter has to change into meters. Centimeters to meters, we divide by 100. So we shall say height of the deck divided by the height of the box. So the height of the deck is 0,9 divided by 0,395. Ended up having the layers as 2,27, which is 2 layers. So remember the question needs by deck, determine the number of boxes. Determine the number of boxes. So on the long side we have 4. On the short side we have 11. And the height we shall take 2 layers. So in other words, it's 11 times 12 times 11 times. These are the boxes that we shall be looking at. The number of boxes that we need is 264 boxes. 264 boxes, that's what we need. Okay, we go to question number 4.2.2. One of the passengers on the sailing ship stated that more than 300 boxes can be packed on the upper deck. If I like that, if what? If the boxes are packed facing up with length across the width and width across the length. What does this simply mean? It simply means, it simply means, simply means, it simply means, it simply means we are going to say the length of the deck divided by the width of the box versus width of the deck divided by the length of the box. Afterwards, we multiply the layers that we already had. All right. So simply meaning substitute into this and we see. So the length of the box, sorry, the length of the deck is 8 divided by the breadth of the box, which is 0.42 times the width of the box, sorry, of the deck, which is 4.8 divided by the length of the box, which is 0.4. Then times the layers, we already got them as 2. So here we are finding out how many boxes will fit on the long side, how many boxes will fit on the short side. So here we have the answer as 8 divided by 0.42. We have 19, whereas 4.8 divided by, okay, we have 19, we have 19.04 because we're looking at boxes. These are 19 boxes. Then here we are looking at we are looking at 7.38, which is 7 boxes, and the layers will be 2. So multiply 19 times 7 times 2, which is 201, 266 boxes. And the claim is what? The claim is invalid. The total number of people on the sailing ship includes the following: 12 crew members made up of 5 and 7 members. Sorry, 5 male and 7 female, 23 male passengers and 31 passengers, 31 female passengers. Write down the probability as a percentage that the passenger who committed, the passenger who committed in question number 4.2.2 is a female. So all you're going to do, because you're looking at passengers only, you're going to add the number of passengers first. So 23 plus 31, you end up having 54. Out of the 54, how many are female? We have 31. But as a what? A percentage multiplied by 100. 31 divided by 54 times 100. The answer becomes 57. A percentage. 57.41%. Determine the probability of randomly selecting a person on the sailing ship who is not crew member. Now here we are looking at it, a person. So how many people do we have? We have the crew members and everything. So it's simply meaning the total population here is going to be 54 plus 4, which is 66, over a person not a crew member. So out of the passengers. So we get the answer there as the 9 out of 11. Explain the term probability in this context. Here we shall say a chance that one of the people is what? Expect. Remember what we need. The moment we talk of probability, we need the word chance and opportunity. All right. We look at question number 5. Question number 5. John G traveled from this place here to Polokwane on a vacation. And next year C shows the direct route from Mabeke to Polokwane. Study the information given in the next year C and use it to answer the following questions. The direct flight distance from Mabeke to Polokwane is given as 1,186 kilometers. Determine the scale to the nearest million of the map in the form of 1:2. So now, what is given? Take note. What is given to us? This is in real. It's in real life. All right. So remember the scale. The scale, when we are determining the scale is written as 1 is to a given value, which is on paper versus real life. So in real life, we've seen that we have 118 1186. These are kilometers in real life. So we don't know what is it on. So now here they're telling us. That means we're going to measure the distance there, the one given in the next C. We shall go to our next C. Next C is this one here. You're going to pick your ruler, you measure this line which is already drawn. All right. When I measured mine, I got 150 millimeters. That was 15 centimeters. So simply meaning 15 centimeters, which is 150 millimeters, are equivalent to 1,186 kilometers in real life. These are millimeters. I want them to be, so I change the kilometers into millimeters first. Or you can do this, reduce it a little bit. It's because we know very well the answer will start with 1. So we make this, divide through by 150. When I divide this, I already have now 1. So when you divide this, what you end up having, we shall end up having 7,90. Please don't remove it on the calculator. It's already there. So what do you do? Because in your calculator, it continues as 6666. Continues with 66666 and a 7 somewhere there. So what do we do? At this moment in time, that's when we change these kilometers into millimeters by multiplying by 1,000,000. So multiply by 1,000,000. So you have so remember the question says to the nearest million. So the million is this one here. So it's 1:8 million. That's my answer there. This is the scale that was used. So we come to the other question, which says it takes about 13.5 hours of driving time to cover the road distance of 1,405 kilometers from Ebek to Polokwane. So determine the average speed for the trip. Round off your answer to the your nearest whole number. Now take note of that. They are saying it takes about 13 hours and a half of driving to cover the road distance of this much from Polokwane. Determine the average speed for the trip. Round off your answer to. So average speed simply meaning it equals to distance over time, which became 1.0 divided by 13. Distance, sorry. Okay, this is that much. Let's say to a whole number, which is 102 kilometers per hour. According to the road safety regulations, the driver needs to rest 15 minutes for every 2 hours of driving. Jogoni rests as suggested. Determine how long the journey will take him if original estimated time is 13 hours and a half. So what you're going to do for me is to find out how many 2 hours do you have in it. So here we shall say, then question number 5.1.3. So we shall come and say 13 and a half divided by 2, because we need to know how many 2 hours are they there. So it will be that much. So whereby you get 7, these are rests, but you can't have 6.5 rests. So these are 7 rests. Each takes 15 minutes. So we have 105 minutes. So what is this in hours? 1 hour, 45 minutes. So we've seen this, but they're asking us how long will it take him if the original is. So we shall on 13 hours 30 minutes, you're going to add 1 hour and 40, which became 5, 1, carry 1, 15 hours and 15 minutes. So you spend 15 hours and 15 minutes. Let's look at question number 5.2. 5.2. 5.2. 5.2. All right, question number 5.2. The diagram below shows a two-door book cabinet and a list of hardware needed for its assembly. The steps for assembling the book cabinet are provided in Annexure D. This is how it looks like. We shall see also Annexure D, which is similarly like this. Right? So here we go. We shall come down and see, look at the items that we have. Let's come to this. Study the Annexure D carefully, as well as the diagrams above, and use them to answer the questions that follow. Write down a set of instructions for step 3 to 5. So simply meaning these are step number 3, step number 4, step number 5. 6 marks, each step will take 2 marks. Okay, let's go to the next one. You see. Step number 3, what would you write as instructions? When you look at it very, very carefully, this is the bottom. It was attached onto the back. They said this was fastened the back side. That means if this is the back side, these are the sides, the left and right. So in your simple instruction would say attach the sides, namely left and right side, onto the bottom and the back panel. In step number 4, attach what? Attach the top. Attach the top panel onto the assembled structure so far. Then come to step number 5. Here's where you stop. Slot in the shelf. Slot in the shelf. It's only one shelf. Slot in the shelf. Together. If at all they had asked 6, it simply means attach the doors or attach the hinges. But they said 3, 4, and 5. All right. This one doesn't matter how you explain it, but as long as you tell us the main point. Here, the main points are, in this scenario here, what are you adding on? We are adding on this side. Step number 4, what are we adding on? We are adding on the top. Step number 5, what are we putting in? We are putting in the shelf. So these are the main words that I want to hear. All right. Let's go to step now. Okay, 5.2.2. Give one reason why a helper is listed under tools needed. Definitely 4. Extra support. Extra support. Identify the tool that can be used to turn the cam pins and the cam locks. Let's kindly look at the cam pins and cam locks. How do they look like? Oh, this is a cam pin. Oh wait, this is a cam. So the tool that we need it to be inserted here like this, or to be inserted there. So what do we need? We need a screwdriver. Screwdriver. All right. Last but not least, we need the user information given above to calculate the total surface area in centimeters. The moment you see that you need the answer, the final answer to be in centimeters squared, please look at the dimensions you have. If they're not in centimeters, change them. So we had to change this to centimeters, which was 70 centimeters. Change this to centimeters. And change also that to centimeters. Now you're good to go. What do we do next? We come and substitute into the formula. The formula tells us 2 open brackets 70 times radius, which is 35, plus 2 into length, which is 70 times the height, plus 2 into width, which is 35 times 9 as the height. At this moment in time, put it in a calculator and you get your final answer. Put it in a calculator, you get your final answer as 2 into brackets 70 times 35 2 into we have plus this into don't forget, add them up. The answer becomes 19,390. Don't forget the units. This marks the end of our discussion. All right, grade 12, what you're going to look at is the paper 2, mathematical literacy. Paper 2, mathematical literacy 2024, prelim. All right, please, you'll go through the instructions. And to me, the most important instruction could be instruction number 4. Start each question on a new page. You make our marking so easy. And we shall see your answers clearly. All right, let's go to question number 1. Kel traveled from Robertson, a town in Western Cape, during the school holidays to visit his auntie Nina. A part of the map of Robertson that Kelly used for his journey is shown below. Study the map and use it to answer the questions that follow. When we look at the questions, that follow, we see that we see the map here. But what I have analyzed so far is that the compass change. The north is facing that other side. Take note of that. The map, when you look at the map, it has a compass, it doesn't have a scale, it has streets, and has some roads there. All right, here we go. Name the road that passes through Robertson Winery and Robertson Wine Barren. When you look at these two places here, let me highlight for you. We have the Robertson and Wine Barren. There we go. This road that passes through it was RA 60.